Yo, what's up, everybody? Welcome back. Today we are doing SIMD markdown processing. Why? Well, because we feel like it, okay? We don't have to come up with good reasons every time, right? We can sometimes get away with some bad reasons. But we were working on the idea of our TV tracker. We wanted to add a notes field to this guy, right? Which we kind of successfully did in Happy Hour today. We can like put some text in this thing and it gets like saved and restored. Wonderful, right? But maybe we want to put some notes in here that are like why I like Severance, and we go to like pretty, right? And then maybe we have like other bullet points like guy from Parks and Rec in it, smile, right? And maybe like we want these like notes to be like nice little bullet lists that we can like show in like properly rendered HTML. So I want to click this preview button and get some markdown, right? You get some like rendered HTML markdown. And so we wrote like the world's like worst markdown parser the other day. It's not very good. It basically only can handle what is in this test document, right? So it can handle like a few heading levels as well as like normal inline text, and then a couple bullets, right? And if we like open up this thing that we generate, we run like zig build and we run our markdown renderer. Oops, we do have to be in the correct environment. Seen worse. Yeah, okay. It's true, there are a lot of terribly offending markdown parsers on the internet that I've encountered. But if we read this, we can look at what it emits, which is, something kind of reasonable. It's got some titles and some bullets. Wow, right? And, I was looking at it and I was like kind of annoyed because it's shit, right? It's shit in a lot of ways. But what we ended up doing was we were like, let's just write whatever code makes sense to us as we like look through this thing, right? And we started like parsing a header. We're like, we'll try parsing a header. And we'll be like, well, I guess sometimes we don't parse a header. Let's try parsing a bullet. And it's just like running like each of these things back to back is silly. We look at the first few characters and go, yeah, not a header. Well, okay. Well, are the next few characters a bullet? No, not a bullet. Okay, then they're probably text, right? Which is like silly, right? You could fold these two conditions down into like one thing. You'd be like, let me look at the next character. Okay, what is it? Right? Just like switch character, jump to thing, right? But like some of the characters are multi-character sequences that we have to look out for. But like we could do better. And then I was like, well, if we're gonna try to go faster, what if we try to go way faster, right? And really just see, can we do like some sort of like SIMD processing of this thing? I've seen SIMD processing of text before, but I don't really like understand it at all. So I thought it'd be kind of like a fun experience to take something where we have like very, very few constraints right now. And I just want to see, can we make it faster by like packing it into some like fat ass registers and like doing some sort of like fancy math on those things? I don't really know. And so that's how we got here. In reality, we know that on our TV tracker, we're kind of making the assumption that all notes are going to be like really short, like in the realm of like, less than 100 bytes, probably less than 500 bytes, almost definitely. But it's still fun, so we're going to do it. And so yesterday I was like, how the fuck do you do SIMD processing? And I just like Googled and I came across like this like SIMD JSON YouTube. I came across parsing JSON at gigabytes per second with SIMD JSON. And I saw like he gave a few tricks in this thing. He was basically saying like, look, you think that like your disk is like the limiting factor of your JSON parsing, but it's not. In reality, like if you're doing like sequential read from this thing, you can probably hit up to like a couple of gigs per second. If you were just like do like naive JSON parsing, you're probably getting like, like a quarter of that, I think was around the numbers that he said in the video. I don't quite remember. But the tricks that he gave were basically like, one, do more things at once. Two, try not to branch, right? Because branch prediction can be like a real pain in the ass. And then like doing more things at once, obviously better. And the way you do more things at once is like you like pack stuff into like you like have like tons of characters, right? You're looking at like 8 characters in a row. Well, instead of looking at each character one by one, you could pack all of those 8 characters into like one 64-bit like integer, and then try to do some processing on that and maybe do lots at once. And then SIMD takes that farther and it says like, look, you have like 256-byte registers. So what's that? Like 32 bytes? You can do like 32 byte batches at once, but you won't be able to do like use like your normal workflow to do that. And so I kind of want to explore what that looks like. So my thought is maybe we like generate a big markdown file try to like do something stupid, like just uppercase everything with SIMD and kind of see what like the difference between like a naive approach is and like a SIMD approach would look like. Then we can try to like find one character and then maybe look for like sequences. To do like more reasonable markdown parsing. But since we're fucking lost, we've never done any SIMD at all, we have to start on like the dumb stupid boy tasks and work our way up. Yeah, so that's the plan. I guess let's get in here and do like SIMD test and see where it goes. Let's start, I guess, by, oh wait, hold on, we lied. I already forgot. The first thing we want to do is generate a big markdown file. So let's do that first. Source gen markdown. All right. I don't think we have to get too clever here. I just want something that's like big enough that we'll be able to benchmark against our other like a normal and SIMD implementation and like see a difference, right? So I'm kind of thinking maybe we generate like, you know, a few hundred megs of text and drop it somewhere and like try to make it look like somewhat markdowny. So we probably want to build this thing, I guess. So let's do a little bit of markdown gen, which was, what was the file called? Gen markdown. Gen markdown, maybe with a dash here so that's nicer to type. Okay. So now we should be able to build this thing. Give him a sec. He's going to recompile the build script, then compile the thing. Uh-oh. I do need to return that, huh? I can't just type the error. Gen markdown returns error. Uh-oh, we are so chilling. Okay. So I guess let's get some arguments, I guess. Let's make, you know, a little scratch buffer. So we're gonna do like get like some fixed buffer allocator, initialize the page allocator, and oops, it's actually the other way around. Oops, var scratch buff is like, you know, let's allocate like, I don't know, man, like 10 megabytes. Fuck it, we can go crazy. Not like it matters at all. Maybe this is only used for arguments, in which case it really doesn't matter. Maybe we'll do 1 meg for now and come back to this. And okay, scratch allocator, and then we have, you know, file path. This is args. We have the file that we're gonna write to. Output path is args 1. Okay, then we're gonna try to open that thing. Which is going to be, I guess, probably relative to the current work directory. Create file, I think is the one that we use to open it for writing. Output path, and with I don't give a fuck arguments. And we probably want to close that thing later. And then I guess we want to start like generating text. We can probably reset our scratch allocator too. Maybe we don't need to though. Maybe there's like literally no other allocations that happen in the whole app. That's like very possible. Let's make some sort of like RNG. Rand default PRNG initialize to 0. And let's get the random interface out of this thing. And I guess we are going to try to generate something that is of the form, like, we have kind of like 3 options. We have a title, we have bullet, and normal text. Right? This is kind of like our 3 cases of like things that we can parse right now. And probably we want to weight these things such that like title is the least frequent, bullet is maybe like, maybe we want to generate like a sequence of bullets and maybe not that often, and maybe we want to generate some normal text as well. Maybe what we do is we like let it, we can let it pick these at like 1/3 rate, and then we can kind of choose the length of them such that normal text still takes up like the vast majority. I think that's probably like a more realistic markdown file. Um, okay. Let's say that we want to like gen words, right? So maybe we're gonna have like, some amount of words that we want to generate. Number of words. Okay. And I think for now, I'm just going to let it go in the range like A to Z. Probably, I don't really care about numbers right now. I think just doing like normal lettered text seems fine. We probably want to like pick a word length. So we probably are gonna do like, so for each word, we're going to generate like word length. So we need the random interface here, right? And we're gonna like rand. We can do arbitrary bytes, but that's not ideal, I don't think, because those are not going to be like limited to the ASCII range, right? What would be nice is if we could generate any random values, and then like, I guess we could just modulo. We could take each byte and like mod the number of characters. Yeah. So we can say like word len is going to be rand int range at most, which is inclusive. Less than is exclusive on the right side. So let's say that we want like, maybe we want something that's like, let's see, words are probably going to be like 2 to 10 characters long or something, right? It doesn't really matter. And then this thing needs a buffer, which means that here we probably need an allocator, which I think probably makes sense to use one of these guys. Bing, bang, boom. Nope, we don't need an allocator. We can just do it on the stack. So this is going to be 10 U8s. And then here we use buff len here. And then you write these bytes into buff. Sure. And then this goes into word len like this. Okay, seems reasonable. Then we need to like take this buffer. So maybe we say like word slice is this. Word slice goes here, and we go for, this guy doesn't return shit, yeah. We're gonna map these into the correct range, right? So we're gonna take the character, mod 26, but then like times 2, I guess, because there's 26 letters, but we want to like lowercase and uppercase. Maybe we just do all lowercase for now. And we map that to this. Okay. Yeah, sure. That seems reasonable. And then we write this word with a space to the output. So here we want like output is an any type because I don't want to figure out the writer type. We probably want a buffered writer. So buffered output is IO buffered writer of output F writer. We need to flush this guy at the end, or else we'll lose some content. And then I think we're good. So if we just, then we need to like write that here, right? So you say like output write all of word slice and a space. Probably something like this. And then here we just like generate some words. So here we take the random interface, we say let's generate like 1,000 words and let's put them into buffered output writer. Okay. He's pissed because it's not allocate, it's alloc. And scratch buff is mad because this needs to write try. And this doesn't need to be like this. Why is stack buffer at all? That's a really good question. I'm kind of against it now. I thought I was going to be doing more allocation, so I was just setting it up. But now I think I don't need it. But we're kind of, we've already got there, so I think here we want to make sure that order of operations goes in the right way. I'm not really sure where the brackets need to go. Now he's pissed off because I didn't pass in an argument, so, generated MD probably here. Those are definitely a set of letters. Hell yeah. Okay, so typically you wouldn't end up with everything on one line though, right? So we probably want to check maybe like for 0 to like let's just say like every 20 words. Can we go like written words is equal to 0? Then this is while written words is less than num words. We do this. Then can we go for 0 to 20? So that we say like every 20 words, we back the fuck out. And then that means that this has to actually go in here. This condition, we need to do if written words is greater than or equal to num words break. And we want to break outer. Okay. Seems reasonable. Then here we drop a new line. Output write byte new line as break return. Yeah, I could. True. True, but I'm not going to. Because it doesn't matter. Okay, 20 is way too many, so can we drop this down to like 10? Sure. Cool. And then I guess some lines should actually be 0 characters long. So I wonder if like maybe just occasionally we put like an extra break in here. So if this is like greater than 8, we do it again. I don't know. If last letter is less than H, yeah, I like that. Actually, this is fine. This feels fine. Fuck it, good enough. Maybe a little less frequent. Yeah, there we go. That's like some text. That's some text. Now let's try to make it so that we, intersperse this shit with some new lines and stuff, or some like bullets and stuff. So actually, I kind of feel like this double new line thing should be handled externally. I kind of feel like it should be handled externally. So we'll say like we're gonna generate words in chunks. Maybe we go like we check we like generate a random number. Sure. This goes to 0 to 1, I assume. Yep, and if this is less than like 0.3, I guess an int range feels better. Okay. And I guess 0 to 3 is just like fine. 0 to 2 even. Switch on tag here. If we're 0, we generate a title. If we're 1, we generate a bullet. And if we're 2, we generate a paragraph. And then else is unreachable. Okay, so here our words is going to be like more in the order of like 100. Speaking of large text, you know this rope structure? I've heard of it. It's something I want to look into at some point. Text editor is on the list of things I want to make, but we're not there yet. Okay, so here, I guess we first figure out like title level. Which is maybe, you know, something between 0 and 6. For 0 title level, we write out a little one of these. I guess here we want to make sure that we write out a new line at the end on conditionally of this thing, which means maybe we do it like this. Let me write one of these. Then I guess maybe we put the, you know, we can do this here. So we don't have to type this all the time. And here, I guess we actually do gen words. And we're going to use like, you know, somewhere between 1 and 10 words here. Sure. Yeah. Why not? He's mad because this thing has to be one of these. And then I guess we do have to write a space out after this as well for it to be valid. Sure. Seems reasonable. Whatever. I mean, it doesn't really matter that much. So I'm not too worried about it. Okay. Then we need some bullets. So num bullets is gonna be like, I don't know, we're gonna have like somewhere between 1 and 20. I guess here we should have at least one character in the title. Oh, that's the number of, sorry, never mind. For each bullet, maybe we, I don't know, we write one of these guys, then we write a space, then we generate some fucking words. Sure. I feel like that's too many. Drop it down to 10. Yeah, blaze it. That's fine. It doesn't really matter, right? I don't actually care that much. We just want like something that like resembles markdown a little bit. I think that here we need to make sure that I actually don't really know what's happening here. I'm going to change this so that when we generate words, we pass in like a line split. And here it's going to be like, we'll just split lines with a new line. Here I want to split lines with a new line in 2 spaces. And here I don't, here like a new line is fine, I think. Yeah, and then gen words is going to take in like line split. And then we are going to write all the line split here, which will help me visualize this a little better. Oops, write all. Okay, so now the problem is that our next bullets are also getting indented, which means that we don't want the last one. I think. Didn't look right still, and then we have to actually write out a normal new line here. Something like that. Okay, that's feeling a little better. And then I think we slap a new line at the end of this one as well. Okay, yeah, that feels... what's going on here? So here we have like a bullet, and the bullet is not being like... We have a new line at the end here. Maybe at the end we put another new line to separate the bulleted section from everything else. Yeah, there we go. That's feeling kind of good. And then I guess also we really should only do this if we're going to write more words. So something like this. Not that any of this matters, but I just want it to look kind of right. Cool, and then... That's feeling like Markdown? Sure, fuck it. And then let's just try to like, do generated MD 40K. So let's just kind of like crank this shit. We just want it to be like kind of, you know, I'm down to go even like another order of magnitude larger. 4 megabytes? Sure. Sure. I mean, we could even go, we could go another order of magnitude, to be honest. 40 megs. Okay, there we go. And so now if we were to parse this through our existing parser, what happens? Markdown main zig. Main zig. Okay, so this guy is hard coding test MD. So we'll just change it to hard code generated MD. Out of memory. Oh, probably because, yeah, we're limiting the amount of stuff we can read. Okay, and then at the end, he is printing. He's printing the data because I wasn't really sure I was doing it right. Okay, so it's definitely like noticeable. And then let's look at optimize, release, save. Really? Optimize. Give him a sec. He's got to think hard. And then we can do like, we can look at poop. And we can poop it. And we can see how slow he says it is. All right. we're just going to put this down here, and we can compare it later. Okay, cool. Generate big markdown file. Done. 25 minutes. Jesus Christ. Okay, so what if we want to like actually do some SIMD stuff now? Let's just do like the stupid shit and uppercase everything. So I guess maybe we'll start with doing this like the naive way, and then we can benchmark it. Then we can try to do it like with SIMD and see if it's like noticeably faster. I would suspect that auto vectorization for this case would be pretty good, right? That seems quite likely, but you know, you never know. Okay, so what are we gonna do? We're gonna like open a file. We're going to open a file, rip it, and then try to write out the output somewhere, probably. So we'll just copy this stuff over. And let's just go for 0. I guess we need some output file. Like create current work directory, create file, uppercase MD, we'll call it. And we'll do this. Okay, then we're gonna go like the stupid thing to do here. If we were just gonna kind of blindly do this, so we go for data character. We would take this and we would say, let's write this out to a buffered writer. So this is going to be buffered output flush. Okay. Then here it's IO buffered writer on output writer. Okay. So we take every character and we say stood ASCII to upper C, and we do buffered output writer. I guess we get the writer here. Const writer like this, and we say writer write byte. Right? Which he doesn't seem to like for some reason. Ah, there we go. So this is like the stupid thing. Let's build this guy. We'll call this SIMD test. And here's SIMD test. All right. Build. Just to save some scratch space on your disk, write to dev SDA. Writing to dev SDA is crazy. Are you trying to fuck with me? Was that like a little tricky? Because surely just overwriting the first few blocks of my disk is asking for like mega trouble. This guy needs var buffered writer. Okay. RM just R slashes is boring. I need a better troll. Dude, that's so funny. Okay. So we can already tell this is going to be bad. And we can call this like stupid way. Just to like save it for later. Okay, cool. So now, I guess we should probably build in release mode. We've got to wait for him to like think a little bit. And that is like noticeable. Oopsies. So if we were just do this on stupid way bin SIMD test, we should see something that resembles, some baseline to look at. Cool. So 359 milliseconds is approximately what we're looking. Okay, so let's see if we can figure out what is the SIMD way of doing this. What is the SIMD way? I guess it's we probably need to check if character is ASCII, right? Then we need to add, is A to Z. Then we want to add some number of add offset between lower and uppercase. And that's it, right? So the first thing we want to do is load into a vector, right? That's kind of the first thing we want to do. I think that Zig SIMD intrinsics are a little bit higher level than the intrinsics you would use in C or C++, right? They're not they're kind of generic vector instructions is my understanding. So instead of doing I don't know, load 128-bit vector or whatever the fuck the function is supposed to be, I think that you just write we have some vector of some width, right? So we can probably assume that we're gonna have if we have 256-bit registers, 256 over 8 is 256 over 8, I should know that number, 32. Right, so we might have 32 byte vectors that we load with, I think you can load it from a slice. So we're gonna go data from index to index plus 32, I guess, is kind of the way you would do this. Maybe kind of more like this. I don't know, we're really flying by the seat of our pants here. In release safe, LLVM will lower them to optimize SIMD, which we should be competitive with Henry ASM. Yeah, that's a good point. Maybe we should start by, yeah, maybe before we get crazy. Let's maybe try to compare a few strategies, right? So going straight to SIMD is kind of like going straight to a bazooka. When we're riding a tricycle, right? Maybe we want to get a little. Let's just start by batching these things in chunks of 8 or something, and just kind of see what happens. Bad alignment will destroy their optimizers. Oh, that's kind of fun. I didn't know that. So if we just say upper buff is something that's 8 U8s. And we now batch this shit. So we go sorry, brain. Var index is equal to 0. We go while index is less than data len. Then we say idx plus equals batch size. So we're doing 8-byte batch sizes right now. Okay. Then what? We go for 0 to batch size. We look at data from idx plus I, and we say upper buff I is equal to the uppercase version of this. Right? That's kind of the thing to do here. Then we write all of the upper buff. And in reality, it would be nice to kind of prevent this writer from being in this loop. So we should actually probably make like an output buffer and then write it all at once. So can we do like scratch allocator alloc, and we want something that is the same length as the input? Okay, yep. And then at the end of this, we're literally just like output write all of output buffer. Okay, cool. Cool. Now, this should be the same. First of all, I think we forgot to look at the output before, but it sure does look like the uppercase version. And then let's see where this goes. Let's see where this goes. You can use a native register size and convert everything to the correct case in 1 cycle. Yeah, I've seen that. I think there's this thing called something they called it like SIMD within a register, I think is the term I've seen for this, which is that like instead of writing like the SIMD code yourself, you write something that is like within you write like something similar but like for your like machine's register length, and then the compiler can automatically vectorize that for you. And you don't have to use the SIMD intrinsic yourself. And can be faster, I think, because the compiler is probably smarter than you, is what I've heard. But we'll get there. So let's look at here. Forgot to write upper buff to output buffer. Oh yeah, I guess here, instead of using upper buff now, we don't need this anymore. It's output buffer at index plus I here. And so here, we probably don't need to do this batching at all. Probably. The compiler will probably be smart enough to do something really intelligent here. Probably. I think. We'll see. We will see. Okay. Let's be careful about not doing this. So it's a SIMD test, I think is what we're calling it. Okay, output buffer here needs a try here. And then error union is ignored down here. So we wait for him to build. He's mad because it's called SIMD test with a dash. And he's ooming on us, which is kind of surprising. Oh, because this isn't big enough. True. True. All right. So now we can kind of like compare the old version, which was the stupid way, and this new version. Well, all we've done is output, like written all the output to a buffer and then written the whole buffer at once. But this is probably way fucking faster. That would be my assumption here. Yeah, you can tell it's way faster. And I think probably we look at like the assembly now to see what the fuck it did. So yeah, we've dropped 150 milliseconds-ish, 160 milliseconds. That's pretty good. And all we did was we just didn't write out to the buffered output every time, which is like reasonable. We're trying to do as little work as we can in this little loop here. Okay, so can we look at what the fuck the compiler did here? So can we look at zig out? Zig out bin SIMD test. And I guess we're looking for main, probably. Where the fuck? What is happening? What is happening? Can we put this in a function? Oh, I don't really want to compile it again. So, I guess we should. So, like, convert to upper. And this is going to take input and output. And he's just going to be this part. And can I ask this to like no inline? So it's easier to find in the disassembly? Okay. Okay. Let's try that. Let's try that. He's mad because output buffer here. My bad. My bad. Using Godbolt maybe is better. Yeah. That's reasonable. If it's not easy for me to get what I want out of this, then I will convert to upper. Okay, no, this is kind of fine. So like, what are they doing here? They're... okay. We'll Godbolt. You guys have convinced me. Because that's too much work to try to parse that without the little helpful messages that Godbolt gives you. Close. All right. Oh, we need const std is equal to import std. Okay. Compile, please. Do I need to make this public? Probably. Does this have to go like export? How do I make this like show up in here? Compilation failed. Ugh. It looks like here we're probably not allowed to put slices in like these export APIs, which is fine. We can just do like, we can do this and we can say like len like this and for 0 to len, and that kind of fixes this, I think. And then here we're just like data pointer and data len, and I think that that's now something that we can send to Godbolt without it getting too mad at us. Oh, you're saying that I can just like ignore it? Like define the thing is used by, yeah, I see. Well, too late now. Too late now. Okay. So what's going on here? So this stuff is like loading up some, oh, this is just like stack saving, looks like, because I mean C API, which makes sense. Then this is like the return out of the while loop, I assume, because we like immediately jump down here. This guy is the while loop comparison, and oh, probably, is this in release mode? No. How do I get this in release mode then? Because this probably isn't using zig build, right? This is probably using like zig build exe, which is going to have an optimized flag somewhere in here. Oh, dash O. All right, here we go. So we can see that there are a lot of like V letters in here, which I believe means vectorized. And so like, what the fuck have they done? Okay, so VP broadcast byte. So instruction pointer plus this guy, LCPIO6 here. So they're putting a bunch of 159s, 25s, and 223s into these guys. I assume that's what broadcast is. Load integer and broadcast. Yeah. So they're taking these numbers and they're like slapping them into these three registers. So 0, 1, and 2 have these like 159s, 25s, and 223s repeating. I'm sure that those are relevant for some reason, but I don't know what they are yet. Then what does this do? Moves these guys from source operand to the destination operand. This instruction can be used to load a vector. So, okay. So he's just taking these things and putting them in these registers. So RDI here is, I assume that this is the input data. I assume it's kind of, we have to double check here. So C calling convention, 64-bit. 64-bit has two calling. One is defined by Microsoft, blah, blah, blah. Oh, can we just go here? We're probably using this one. So we're at RDI, RSI, and RDX. Okay. So presumably the first argument is RDI. So this is like input arguments, and it looks like we're trying to load like huge chunks at once. Then this is the output, right? That makes sense. And so what the fuck are they doing here now? Rax to B159, you'll see what it's doing. Okay. That's like a lot of letters that I've never seen before. So here they're adding basically each of these guys that they just loaded. They're adding in the things in YMM0. So they're adding 159 to everything. That's what this stuff is doing. I assume we should double check. Yeah, so I assume that the B there stands for we're adding at the byte level. Oh, wait, this guy tells you. Performs a SIMD add of the packed integers from the source operand into the dest and stores the packed integer results in the destination. Sure. Cool. Cool. Then this thing, what's this thing do? Performs a SIMD compare of the packed unsigned byte or word integers in the second source operand to the first source operand and returns the minimum value for each pair of integers to the destination. So they're checking if this thing is less than YMM1, which is LCO7, so less than 25. So presumably that's like kind of related to something that's going on in here. So this is probably is lower. So lowercase a is probably something. Man ASCII. So lowercase a is going to be hex 61, or in decimal that's 97. So that's not either of these numbers. Okay, so we'll see. But we're trying to convert something that goes is lower, return this thing bit masked, else return the thing as it was. I would be interesting to see what these are in hex. Can we do like hex 159? Is that how you do this? 9F? Binary, like format. $159. Okay. So he's dropping a couple bits, maybe? No, because he's adding. Okay. Weird. Does this thing like overflow add? 0B 10111 should be obvious when you consider the range of all ASCII common ASCII characters lower and upper. I see. I see. Does that match anything from here? No. Okay, so they're getting kind of clever. Like, this is somehow converting. Yeah, we'll see. What is 25? Okay. So they are taking, all these guys are adding 159 to them. Then they are... They're only looking at YMM11 here. Where does 11 come from? 1 and 7. So this is 1, 7, 1, 8, 1, 9, 1, 10. Okay. Okay. And then here they're doing something kind of crazy. They're like, add this shit to the thing in 0. I don't know what this does yet. Performance and compare the packed unsigned byte or word integers in the second source and the first source, and returns the minimum value of each pair to the destination. Okay, so they've added 159. Then they're taking the lower of 25 and the added 159. And then they are doing a comparison to see if they are the same. If a pair of data elements is equal, the corresponding data element in the destination operand is set to all ones. Okay. So can we see, like, can we try to rationalize this? Okay, that's interesting. So this is probably, does this probably overflows handled with a wraparound. Cool. So that makes sense. So basically they're trying to make A 0 by adding 159. That makes sense. Then this guy is doing compare a packed unsigned byte or word integers in the second source to the first source, which is the minimum value. So he's comparing this thing with 25. He's trying to see if he's less than, he's trying to see if he's lowercase letter. Aha! Aha. Okay. So this guy basically makes it so that A is relative to 0. Then this guy's comparing him with 25, which is doing that is lower check. And he's storing the results in 7, 8, 9, 10. What is this again? Oh yeah, it's the same. Okay, cool. It's weird that the operands got flipped on all of these ones, but I'm sure it doesn't matter. I'm not sure, but I'm pretty sure. The results are going to be the same. So then this guy is doing a bitwise AND with what is in 2 and the original. Right, so he's got the original letter, and he's ANDing that with this thing, which converts it, I assume that this is the bit that you have to set to get from upper to lower, or from lower to upper, right? If we look at man ASCII here, we can see that like the lower and uppercase line up with each other by an offset of hex 20. Right, so they're probably just unsetting that bit here. Right, I bet you if we look at this byte 223, we're seeing one bit unset here. What is it? It's you do this dot format 223. Yeah, so this is unsetting that hex 20. Right? Yeah, that makes sense. That makes sense. Cool. So, what I don't understand here is how are they handling the fact that I might go out of range? Right? What if there's less than this many bytes in the input? Here probably they're probably doing something here. So they're saying like check if there's 128 bytes left. Otherwise, go to here, which is probably I see. So they've kind of stacked it. I see. So here they're doing 4 chunks, right here, and then here they're only doing 1 chunk at a time. I think they still have the same kind of shit here. They're using XMM registers, which are, I assume, smaller. XMM is the low half. Yeah, so it's half as large. So I assume that these are now 64-bit registers. If we were at 128-bit before, or what were we at before? This is 32, 64, so 32 times 4. 128. So now we're doing 64 bits at a time. But what happens, like, do we then fall back somewhere else to doing, like, 32 bytes at a time? Yeah, so these guys are doing it with 32 bytes at a time, maybe? Byte pointer? Maybe not. I need to know, like, the x64 register naming. Like, 30, like, x86 register naming. Like, I just, fuck off. I didn't mean to click that. I just want to know, like, here we go. Rax, so REAAHAL. That's kind of, okay. So does that line up with this? So we're in, like, R's, but these don't look like that. I've never seen these, like, R11B, R9D. Like, what the fuck is this? I've never seen this in my life. What does that mean? R9D register. Like, what does it mean? Okay. So D's, I see. So they have extra numbered registers. They have numbers 0 to 7 are letters, and then 8 to 16 are numbers, and then they throw D's, W's, and B's on them to like downscale. Okay. So what they're doing here is they're looking at the 32 bits at a time now. Then I assume that we're going to scroll down and see lower chunks. No. So maybe this is just byte by byte and I misunderstood. Yeah, it could be. Byte pointer probably is the piece I was missing here. So they're saying like you can load this like this like 32-bit word from this address, but only take 1 byte at a time. That seems kind of reasonable to me. Sure. So here they've just got like kind of like the fallback case for once you run out of space with 128 bytes at a time, jump down here and do byte by byte. Sure, not 128. Sorry, what was it? Maybe it was 32 times 4. Yeah, 128. Okay. So nothing in here is crazy, right? Nothing in here is like, this is like what you would do if you were to just kind of like do it by hand. So it seems like it's done a pretty good job here. Now you could probably help it out. I assume that you could like over allocate to pad this shit up to 8 bytes, right? I wonder if you did um like this guy could return this guy rounded up to 8 or like rounded up to some interval. And then that way you don't generate this extra code at the end, which is maybe worth it for really big files, right? But maybe not. I mean, like I guess in reality, either option is doing something extra, and in either option, you're literally only doing this one time. The only reason that you would want to do that is to try to help the branch predictor, probably, right? So like you could go like a little bit faster, probably, if the branch predictor doesn't immediately start guessing the right branch, but it probably does. So it's probably not worth it. I think that's the only gain you get from that. Sure. Okay. So I think that this thing is we've kind of learned here that it's not worth doing probably not worth it in quotes. Yeah, I mean in this world where none of this is worth it. He says probably not worth it. Okay. But that's pretty interesting. So we've kind of learned that like in this case, a simple while loop is getting auto vectorized like pretty well, right? And now we can start moving on to like kind of a more advanced case where I want to find one of n characters, right? So for like real markdown processing, eventually we're going to want to find like sequences of characters, but for now, I don't want to do that. Right now I want to start with something simpler, which is let's just look for the the markdown characters that we know like mean something interesting, right? So we know we have new line means something. We know that we have this like hash that specifies titles. We know that we have stars, which are used for bullets and emphasis, and dashes, which are used for bullets. Is there anything else we need to think about? Numbers are also interesting in the context of lists, but I'm going to ignore that for now. Okay, so let's do like the stupid thing, double backslash. Yeah, but I don't want to handle that yet either. I'll have to think about backslashes later. I think this is like a fine initial thing to play with. Fuck it. Let's look for backslashes as well. Fuck it. Those are interesting. These are interesting components. So how do we want to test this? We want a function that will tell us all of the interesting components. Right? So what should this guy do? I guess he should walk them all, walk the whole file, and let's just write out the interesting indices into a buffer. Let's do that. So here we are probably going to, let's not do this as like this exported function. Let's try to bring it back. I think it was a good point that we can get away with doing this to force it to compile. I think. It was something like that. That doesn't seem to be, maybe like this. Here we go. First of all, let's just see if doing it this way compiles in Godbolt before we get crazy. Go back to Godbolt. We paste in here. See, like that. I keep forgetting to say import stood for the to ASCII. Oh, you're saying I do it comp time? So you're saying I do, oopsies. This? Compiling. No assembly to display. God damn it. Am I crazy? How do I like force? Oh, you need the address. You're right. You're force zig to emit function. But export was like what we were doing before, and it doesn't let us use slices. Call it. But like, I don't want it. I don't. Export the pointer. Yeah, that doesn't seem crazy. Const export. Pub export const. Pub const. Maybe. Export a C function that calls it. Yeah, I guess that's the way. Fine. Fine. I guess that is a little nicer though. Right, we can just do like something like this. And then do convert to upper input 0 to len and output 0 to len. Ugh. I was hoping to avoid it, but I guess it is what it is. Compilation failed. Am I fucking stupid? Oh. Alright, fine. This will work for now. It's good enough. Good enough. Also, hi, Christoph. Yeah, hi, Christoph. Good to have you here. Okay, so let's try to do like a stupid version of writing down all of the locations where there's an interesting character. So we're gonna go like for. I know that it's like stood mem, like index of any, right? So this guy will try to find. I think this finds one of the values that are in here. Yeah. So he goes for each item in values, check if the thing is there. Otherwise, and like you're good, return it. Yeah, that seems like a reasonable implementation of that. So let's just say this does not quite do what I want though. We kind of want like some sort of iterator, right? So let's do, but we can follow the same concept. So we can go for cars is, we have this guy, this guy, this guy, this guy, this guy. These were our guys. And we go for cars, we have a C. If input idx is equal to C, then I guess we write out to output at out index is equal to index. So that means that we have like out index here, and our outputs are going to be a usize vector now. And then here, we're kind of chilling. I guess out idx plus equals 1 here as well. Okay. And this is now going to be called find interesting. Find MD chars. We'll call it. We'll call it. And here it doesn't, we don't actually care what this does. And then let's call it once just to make sure that it's doing something sane. So write all output buffer seems reasonable. And then here we use usize here. And I don't really need it to be optimized right now. Expected type found U8. Where is this? This is at 45. True. Little bitch. Such a whiner, this guy. Then this guy needs to be like I guess we have to do this. Gross. Like, we can't just write the byte value anymore. We have to, like, stud format int, I guess. I guess we just print. All right. Like this. We get a writer. We stick that guy here. Surely. Okay, so he's mad because somebody is out of memory. Because this guy, again, just needs to be, like, bigger, though. I mean, in reality, there shouldn't be that many of these, so can we, like, just say that there's maximum, like, 500 interesting characters? Surely. Nope. 1,000? I don't really care. I just don't want to... Okay, well... I don't know what I expected. Surely, like... 1 meg. 1 in 100 characters. There we go. Okay. So, the question is it reasonable? He's mad. Okay. So, okay. Sure. Fuck it. They're, like, incrementing and sparse. I'm not really too interested in, like, how correct this is. I guess I'm more interested that this, like, stays the same later. So we'll call this, interesting chars simple MD. Okay. And then we can kind of copy paste this into Godbolt and see if it's doing what it's doing. Maybe it's doing something cool. Maybe it's doing something not cool. Oh, this is wrong, by the way, as well. This guy needs to tell us how many interesting characters there were. He needs to return out index. And then here we need to maybe discard here, because who gives a fuck? And then num outputs is this, and we go 0 num outputs. Okay. Fine. We'll fucking write down the return type. If you want us to write down the return type, write down the return type, you fucking whiner. Compiler, always making me type the right thing. I think a decent way to do this would be to build a 64-bit mask of whether each chunk of 64 cars is equal to one of those, and then maybe use CTC to get the next index. Not quite sure what you mean. I think maybe what you're saying is reasonable. I just don't know. Okay. So if we scroll onto the bottom, we're not just seeing like garbage. Seems reasonable. Seems reasonable. Okay. Compiler could also guess right thing. Dumb shit. Yeah, God, what an asshole this guy. Making me say what I want precisely. I forgot import ST again. We don't actually need ST this time, which is hype. Doesn't it constantly annoy you switching between files and terminal manually? I don't even know what you're asking. What do you mean by manually? I'm typing like 2 keys. Okay, so this does not look like it auto-vectorized at all, which is exciting because that means that we can try to vectorize this and see what happens. See what happens. So let's copy this to, what is this called? Like, find interesting simple. Okay, and then maybe let's also get check, like make a get checkpoint here so we can come back to this code. Okay, and so I don't know, let's just be clear here. I don't fucking know SIMD at all, right? But I did see a trick in this YouTube video I watched yesterday from the SIMD JSON guys. where they basically said like there's this function that you can use to like map, like you can make what is essentially like a lookup table and like map characters to other characters, right? And so like I'm thinking that surely we could do something that's like map these interesting characters to ones, right? These go to ones. And then I think that there's an instruction somewhere to be like, find indices of values that are true or something. Maybe you map these to 0xff actually, and that are 0xff. I think I've seen this instruction. And then you can like use that. Then you can probably use like count leading zeros to find the interesting indices. Maybe I'm not really sure. But this is like, you know, I clown on the AI guys a lot because they're fucking idiots. But this is kind of like a place where I would like to see what's out there. So if we were to ask this guy, like, how do, like, if I want to find all instances of a character of some set of characters with SIMD, what is a common approach? Question mark. Maybe this guy will like give us some ideas, right? So load, okay. Dude, I love like they really like lists, numbered lists, and they really like putting stuff that's like I don't. Okay, obviously, you put the data in there, right? So he's saying compare bytes or compare words, which is not really exactly what I want. Because I'm like, well, like in one instruction, can I check if I match like how what you're saying is like that comparison will only match one character, no? Can I match one of many characters? Question mark. This example code looks close to like the only best way. I feel like I'm missing something though, because he's only checking one character. That will match C, B, or A. Okay, so maybe I just misunderstood. He says you're right. To match one of many characters? Is this just the same fucking thing? He sets these guys to be like, here, check for any of these. Then load, compare. This is the same fucking code, is he not? He's such a god. Fuck it. Okay, so it's fine. So just don't say I'm right. Tell me I'm fucking wrong. Tell me I'm wrong. Okay, I know I started like this thing by saying I clown AI, but like to be honest, this is useful, right? So like I must just not understand what this thing does. Compare for equality of packed bytes, words, double words, and source vectors S1, S2. If pair of data elements is not equal, the corresponding data element in the destination vector is set all ones. So like, am I fucking high? Like, it seems to me like what I would have guessed this did that is that it would check the first character is C, the second character is B, and the third character is A. That's what I would think this does. But I mean, it's clearly not. So what am I missing? If a pair of if a pair of data elements is equal. Oh, I see. So he is probably going all of them at once. Probably. I mean, we can check this. And then also, like, it gets, like, extra hard here because, like, I don't think Zig has, like, these intrinsics in this way. So we probably want to, like, surely, like, Zig has some way to do this, right? Can we just do, like, we just, like, slap this into Google? Zig, SIMD, comp, EQ, maybe? What's this guy saying? first index instance of a character within a body. So this is similar, but not the same. Select parallel if. That might be it. Zig lang reference. If only there was a standard library if something's right. Look, we're trying to learn, man. Calm the fuck down. What's this guy do? So selects values element wise from A or B based off pred. No, that's not what I want. I don't think. This is like picking one or the other. Okay, what other instructions do we have? Splat, shuffle, select, reduce. Splat, shuffle. So splat's like basically like broadcast this shit. Shuffle is... This is like the lookup thing I feel like that I've seen before. Where they're like, given element from A or B, positive numbers select from A, negative select from B, by selecting elements from A and B based off mask. So their example here is that they say like hello world, and they punch in 23110, which would give us 23110, right? So this is kind of like sampling from this, essentially. But it doesn't really feel like they have the like built-in of whatever the fuck this thing did. Right? The this thing. Unless like equals or something does that, but I don't think it would. So I am kind of down to look at what's in stud SIMD now. I am down. Which I guess is here. Alright, what do they have? So the problem is I don't really know if any of these are really what I want. First index of value is like close. Joins two vectors and shift them leftwards. Prefix scan. Yeah, I feel like I'm missing something. Stud mem equal bytes. Oh, I see. What is this? What is this? Stud mem equal... No, but this isn't what I want either. Right? This isn't what I want either. I want to know if it's like one of many characters. So I'm not really convinced that I have something to look at. Right? Because what we were looking for, like, when we looked at the implementation of... What was it? It was stud mem index of any, right? This is like, give me a slice, check if there's an index of any of these guys. This guy has no SIMD in him. Okay. I mean, we can always ask this idiot. He'll probably lie to us, but like, is there a Zig equivalent of this guy? I'm sure there must be. I think it's saying to look at the implementation of equal bytes, but I feel like that's not what I want. Like, I understand that there's like an implementation there, but unless I'm missing something, I don't see where in this guy that he would do what I want. That's kind of more what I was getting at. Right? He's like, because he's going to be comparing one byte for one other single byte, I would have assumed. There's also like a lot of stuff. There's a lot of numbers in here. I'm just looking for, is there an equivalent to this guy? Do you think that this thing exists? What do you think the chances are that this exists? Okay, you know what I want to do? I'm like not even still 100% sure that this fucking equal function does what I want. I mean, you guys are saying that it does, but I want to fucking prove it to myself. So maybe we start by getting into C land, trying to like do something with that function, and then coming back once we're at least confident that it's doing what I expect. And then we can kind of like compare, like, It's just possible that I just don't understand it yet. So, compares packed bytes of two source vectors. Performs a SIMD compare. I'm pretty sure you're looking for VP shuff B, which Zig doesn't have. I think at shuffle is the closest, but the mask must be comp time known. Right, so you would like shuffle, then compare. I could see that working. Right, so you could shuffle everything just to like you could map everything to like true or false, and then do an equality comparison, then find like the indexes of the trues and falses. But I do want to see if this thing does what I want to try. I want to try this thing first. So I guess we'll look at the idiot's code. Wrong guy. Wrong idiot. Okay. This sounds right. Okay, and then I guess I'm down to just like straight copy paste this guy. So he's like, here I'm going to set. What is epi here? I'm sure that epi means something, but I don't really know what yet. I assume it's like elements per something. We could maybe, this seems like the kind of thing. Does he know what it means? What does epi stand for in MMZ epi? He might. He might. Sure, whatever. I mean, that lines up with my guess, but I'm not really satisfied. Then he like loads stuff from the input. Then he compares it. Okay. So can we just like, I guess, make some input and output? Find any chars. So hello world. And maybe can we we probably will want to pad this, but we'll figure that out later. So hello world, can we do, how do you fucking do arrays in this language again? Dude, my brain. Input equals hello world. And then am I allowed to do size of input? I know that like half the time this shit doesn't work and half the time it does. So let's just start there because it's been a minute. It's been a minute, okay? Okay? Just cut me some slack. LU, there we go. Okay. 12. Okay, yeah, so this does work. Then let's check the output and the output link. So we need some sort of like output. So output being a char here is stupid. This should be size t. So stood def, I think, is where this comes from. And then I guess we can just make this 100 because we know that's plenty big enough. And 100. True. He does want, I guess it's not like that. So we want size t output len here, and we pass that in here. And then do we think this is reasonable? Okay, so this is 12. So 13, 14, 15, 16. Okay. And then can we, for int I equals 0, I is less than output len, I plus plus, we're going to say output I printf this guy. Which he doesn't like because this would be LU probably again. Zero, zero, zero. So clearly whatever we've done is not correct. It's kind of fun. So input line here. I guess we need to. I guess it's time to GCC dash G GDB. There we go. GDB test. Let's just see. You know, the idiot might be an idiot, but maybe he gave us something that's like at least a little bit correct. Okay. Optimize out. Hell yeah. Love to see that. Okay. Can I print this as binary? GDB print as binary. Is that like allowed? P/B. Oh, is there such a switch? /T. What the fuck? Okay. So he's saying, I found 3 things here. ELL. Oops. Oh, I see. No, he's looking for the set values on here. So we are looking for E or else. That's not what this is either. So he's saying compare data with pattern. Okay. And the mask, I assume, should tell us which elements of this thing were set. Right? So seeing ELL does make sense, but I would expect to see like a mask here of like 0B01110 or something. Like something like this. Unless it's just not doing what I expect, which is very likely because I have no idea what it's supposed to do. Okay. Yeah, I mean, this is clearly wrong, right? Pause 11. Where does pause come from? Oh, here. So they count number of zeros, count trailing zeros. Oh, I see, so they're going this way. So like all of these guys, no bueno. Okay, so I feel like I just don't understand what this mask is. I must not understand the mask. Right? I must not. So if let's just try only putting an L in here. Let's see if that like changes this at all. And then can we do like printf? Can we do like a Boolean print in this language? I think you can, but I'm not sure. Okay. So this gives me 4 1s. Oh. This gives me 3 1s. This gives me 2 1s. What the fuck? Are you leading as 0? Oh, yeah, that's a really good point, huh? That like I don't really, yeah, I do probably want to format this as like how many of these are there supposed to be? This is a 32-bit number. How do you do this in this language? 032b maybe? Ah. Okay. However, I still don't think this really makes a lot of sense. Getting just like 4 1s in the middle of this thing doesn't do what I would expect this to. Oh, this is telling me maybe which nibble. Yeah, 4 1s just doesn't make sense at all. We need to look at the documentation of this again, obviously. Well, can we look at comp actually? Looking at comp might be interesting. Is this thing like possible to print out? LL? LLLL? No. Can I like print 120 like SIMD value C? Print functions. Oh, this is just he's saying like you have to make them. Okay, fuck it. Um and can we do like can we do this? Is this allowed? Or is this shift operator? Do you need to do some sort of like intrinsic to get it out? Um we'll figure it out. We'll figure it out. So oh, it's like a vector of two long values. So how do we like pull it out? Extract values from vector C. From M128I. Bump, 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 bump. Oh, that's cool. Extract these. Jesus. Store to an aligned temporary array and access the members. This sounds more like my type of shit, dude. Yeah, I could get behind that. So we put this to some output from comparison. Comp data. And can we just do like this? Like, let's just like really fuck our shit up. And then we probably want to go 1 then 0 because I assume Little Indian might, probably is the same. But, you never know. And then here we want to make sure that this thing is, 64 here and here. Sure. Let's see what that does. Okay. Okay, wait. So maybe this does make sense. So this is saying that they found at like some byte offset, they found 1, 2, 3, 4 things in a row that match, which turns into 4 things in a row that match down here. But there's clearly not 4 things in a row that match in the input, right? Like, does that have to be -1 for to ignore the null terminator? Feels like maybe. Yeah, there's something I like clearly don't understand. Like, there's something I clearly don't understand here. Clearly. Could the problem be that Hello World isn't 16 characters long? Yeah, but I was trying to like intentionally pad it out with spaces. Right? So like, say we do this. We should have 16 spaces here, or sorry, 8 spaces, 4 C's, 4 L's. Right? So if we're like saying like only find me spaces, like I just feel like this must not be doing what I expect. Which, to be fair, I did not expect this to do what it was doing when in the DuckDuckGo or the fucking AI answer either. to be fair, I kind of expected this to be like, can we do this? Can we fucking how do we like broadcast in this, in like C broadcast SIMD? I know I saw something about like broadcast somewhere. What I expected, here we go. Yeah, not quite. Broadcast epi 8 maybe? Yeah, let's go, baby. This is kind of what I was looking for. Take byte elements from the source operator and broadcast to all elements of the result vector. Yeah, so can I just write like a space in here? No. Ah, fuck it. Fine, we'll do it this way. How many are in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, surely. This also not doing at all what I expect. Like, in the slightest. So if I'm like, find me some fucking spaces, and I give you an input that's like a fucking bunch of spaces, should our comparison not just like give us a fucking bunch of answers? Like, what am I missing here? I mean, I'm missing a lot, right? But it just feels like it should do what I want. And wavy. We need to read the documentation for this. You got some FF, but I only got like one. Right? Like, unless I, yeah, okay, so what does this do? Performs a SIMD compare for equality of packed bytes, words, double words, or quad words in source vectors S1 and S2. Cool. If a pair of data elements is equal, then the corresponding data element in the destination is set to all ones. If a pair of data elements is unequal, then it's all zeros, right? So what I would have expected looking at this thing is like, if I'm feeding it input of just like a ton of spaces, like surely somehow I should be able to get something that looks like 0, 0, 0, 0, right? And then FF, 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 right? Surely that should exist, right? But it means like, that's not what I'm getting, which means that like, I clearly don't understand what's happening at all. How many spaces do you expect to find? Like 8. I expect to find 8 spaces. And it's finding 1. As far as I understand. Oh, god damn it, dude. Never mind. I'm just a fucking dumbass. Fuck. Oh, okay, this makes way more fucking sense. Makes way more sense. I thought that I was passing this string down, but I was passing hello world, which is really funny. Okay, so that makes way more sense. Okay, so now, what if I pass L and C in there? Okay. So here, we're seeing 1, 2, 3, 4, 5, 6, 7, 8. That makes sense. What is going on? What is going on here? So how many characters? I'm passing in characters at 16 byte intervals. So here I should really only expect the lower 16 bytes of this thing to be reasonable, right? So this should be like, I should be looking at this thing like it's a unit 6. Oh yeah, wait, that makes sense. So this is 8 bytes, 8 bytes. Yeah, okay. And then maybe I have this backwards. Yeah, okay. So now the last elements are Fs. And then I still feel like I'm doing something wrong because it feels like there's like way too much stuff in here. But I don't really understand why. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So why does this feel like so fucking fat? Right? Shouldn't my 8 bytes here be like half the input? Yeah. Surely. So I probably want like uh this. No. Oh, because it's at the bottom? So I want to like take the pointer from this thing. And then dereference it. And like add some offset. Jesus Christ. 8, 16, 24. Is this what I'm expecting to see? No. Whatever. I'm not going to think too hard about it. Okay. So we've got a bunch of garbage on the front. Probably because we're jumping in element. Like, I'm missing something here where, like, we're going through 16 bytes at a time. These 16 bytes are comparing with this 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So there's 16 things here. And then how am I getting, like... Oh, it's because I'm running fucking... I'm just a dumbass. 8 here. And 8 here. There we go. That's a lot more reasonable. Maybe 16. Yeah, 16 characters of zeros. There we go. Okay, we're finally there. We finally fucking made it. Okay, so this makes sense to me. This makes sense to me. We pass in a string with a bunch of spaces at the end. We say compare with spaces, and then we get fucking a mask of things at the end. We're fucking chilling. Then at the end of this, we should have 16 bytes of binary, and we see this is kind of flipped from this, but that's okay. Cool. And so that all makes sense so far. Now, if we were to say one of these things, also look for the character C. Like, this is behaving exactly how I expected, by the way. Exactly how I expected from the beginning. This is exactly what I want, what I thought was happening. So I think what this thing is doing is not what I fucking asked for. And I was right. And I'm so fucking vindicated because I was told that I'm not right. But like, what I think what this is doing is I have like some text A, B, C, D, A, B, C, D, A, B, C, D, right? And if I compare that with A, B, 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 C, 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 I think what this is going to do is we're going to get 1 here, zeros everywhere till here, then 1's here because the B's match up, zeros everywhere else, and then 1 here because the C's match up. This is what I was expecting to get, and it is what we're getting. It's not what I fucking asked for. Okay, I'm vindicated. Fucking vindicated. Okay, so this is just not what I want. And also, when I was like, can I fucking get this instruction in Zig? It's like, yes, it's just fucking equals equals. It's just equals equals on the vector. Okay, we're so back, baby. We're so back. I'm gonna go back. Okay, so you know what? Like fucking like 30 minutes ago, maybe an hour ago, when I was like, fuck AI, but in this case it's good. You know what? Fuck AI, in this case it's not good. Fuck this asshole. Fuck, he just sent me on the fucking wrong path. Oh, every time. Why do I ever fucking listen? God fucking it's fine. We're fine. Okay. I'm going back to my original idea, which I thought would be fine. AI wastes more time than it saves. Unless you're dumb. Okay, so fuck everything we talked about, fuck that shit. I want to go back to my idea, which was that we should be able to convert these characters into basically like yeses or nos, right? So I think that his idea of using like count leading zeros and like whatever that thing that was like bit mask this shit was, I think that was fine. I think. So I want to use shuffle. So this guy basically says like given some input map to some output. And if we want to like match these specific characters, we can, I think, do this mapping in like two halves. So the problem here is that the shuffle, if you were trying to map like every single character, you would need 256 lookup table slots, right? Ew, gross. Where are those 256 slots coming from? I don't think that we can do that. I don't think. We should look at the fucking docs for the at vector thing again. Or it was at, okay, shuffle. So it's actually possible that that would work here, but I think it would maybe be stupid. I think what's more reasonable, given that what we saw in here, right? His the comparison buffer here was like 16 bytes long. A 16 byte comparison is like totally fine, and this matches up with what I saw in like that SIMD JSON video, where they were basically like, just do it in two halves, right? So we'll say lower half of this, or this, or this, or this. We will map these to maybe like 1, 2, 3, and 4, right? And then we'll take the upper half of these and also map them to 1, 2, 3, and 4, right? Then we will do comparison on the upper and lower half to see if these guys match each other, and then take anything that is non-zero. Or yeah, any of the, and then we like do the same trick where we try to like count leading zeros to figure out which of these indexes there are. I think that makes sense. I think that makes sense. So let's think. So lower masks. Yeah, I guess. Can we just like do this? Here. Okay, so we have this guy, this guy, this guy, and this guy, and then I think it was double backslash as well. Hello? Oh. Okay. I guess we leave these guys, then fix like this, and then bring this in like this, and comment this out. Okay, so our lower masks are... Okay, so there is overlap on here, which is interesting. Which means that we can't do this 1, 2, 3, 4, 1, 2, 3, 4 thing. Because these two characters need to be distinguished somehow. But I guess there's probably some way to be like, does the upper half match and the lower half match? Right, so we know here that we have like, this guy goes to upper to lower 3. No. Yes. Right, so we could compare each of these characters individually SIMD-wise, which would maybe still be faster than this, but I would love to have some sort of like direct mapping, which I think is possible. Right, so we could do like, we could do like, I mean, if we were to do like upper is equal to 2 and lower is equal to 3, like for every character in the like SIMD sequence in the register, that would just be stupid. We might as well just go back to doing like this shit, right? Where we compare every single character. We might as well just do this, right? Where we put like a fucking like hashtag in every one of these, right? And then we can just like check with equality. But that's not what we want. We want to do something smarter, right? Where we can kind of compare, we can get like any of the interesting characters in one shot. So maybe we can do something. I wonder if we can get clever. In this scenario, we know that like upper 0 is new line. Upper 5 is backslash, and upper 2 is one of these 3 guys, right? Okay. Then we know that on lower, there's like unique 3 is this, D is this, A is one of star and new line, and C is the backslash. So there's kind of like there's it feels like there's something that you can exploit here to say that like these guys are unique. And so you want to check like if we were to map, say we map like upper like say this is 0, this is 1, and this is 2. Or maybe we do 1, 2, and 3. And then 0 is like everything else goes to 0. All we have to know, I guess we don't care which character it is yet. We only care, in this case, we only care that there is a special character. Right? So we could kind of do... I feel like we're so close. What if we did something bit masky? Something bit masky. So this is like 4. Okay. Then we know that this guy goes to bit 4 and he lines up. This guy goes to bit 4 and he lines up. This guy, we're not so lucky, right? Because these guys correspond to different guys up here. So we can't just check if like the bits match up. No dice there. I guess though, is there any chance if we just mapped, like, if we just did comparison with this half and with this half, and all of these guys, we just said 1 on any of these. And we said 1 on any of these. Right? Hear me out, hear me out. Is there any combination of this that would be wrong? Maybe. Maybe, right? Let's see. So if we know that we have 3, D, A, and C, so that means that we would have 2, 3, 2D, 2A, and 2C. So 2C would be invalid. Right. So we can't just map everything to 1s. We have to be a little bit more clever. We have to be a little bit more clever. And I feel like it's possible because that's what he said. He said he did something like this in this YouTube video. He just said he was very clever with the lookup tables. And so now we're kind of seeing why this is difficult. Okay. Okay, this is fun. This is a fun little puzzle. So we have 2 plus A, D, or 3. 0 plus A, and 5 plus C. These are our unique characters. So it seems like 5 plus C is easy, right? We just say, if we see a 5 on the upper half or a C on the lower half, we map that to like the backslash character, the backslash enum value. Reasonable. That's totally fine. And I wonder if we can like if we could get like an enum that has like potential of like these, right? Then potential and potential backslash. Okay. Then you could like maybe resolve these somehow. Right? So if you use bit masks here, you say like this is equal to 1, this is equal to 2, this is equal to 4, and this could be like the high bits. Then you have low bits is potential hash, potential minus, potential star, potential new line, potential. What was the other one? Backslash. And here, I don't think that you can get as lucky here. You can't use 8 or 16 here. Can we? We have 8 bits. Yeah, wait, so we do. We can. We can use like 1, 2, 3, 4, 5. Yes, this is 5 bits, this is 3 bits. Okay. So then surely there's some way to like map these guys. Right? So we know that like if you OR these together, are we just creating the same problem? I think we're just creating the same problem. If we OR these back together, we have unique combinations for each one. But then we already had unique combinations for each one, which was not simple. Not like this is the whole problem is that we didn't want to do a 256 byte lookup table. Okay. So you need to do something more clever. Interesting. Interesting. This is a fun game. I'm sure it's possible. Well, I'm not sure, but I'm like fairly confident it's possible. I just don't know what the I don't know like where we're supposed to go yet. So if we do this, make the backslash n 2 and the backslash this guy 4. Or we up here use them as like 8 and 16. The only things that we need to disambiguate here are these guys. So what if here we do this as 1, 1, 1? Like this. We say this is 7. So then we compare this with this. And we know that if we AND these guys together, one of the bits will be set. Oh, but we can't map this on the low side. Right, because these guys have to map to the same thing. But we can do the same thing here, maybe. Does that work? So this guy can maybe get a tag of like 8 and 4. or something. Well, then if we and these guys together, we'll get ones. I'm worried about like a false positive, but I think that might give you something sane. So the only problem here is if we get seven and 4 here. So that means that this started with a 2 and this ends with the yeah, so 2A is fine, but then also oh wait, maybe this is fine. So we match 2D. So this guy has to this case was anything that starts with a 2. And is there anything in this set? So we're going to be matching against 2 and this guy. So we're going to be matching against 2, 3, 2D, 2A, and 2A. Wait, okay, wait, that's hype. Or 0A. I think that might work. I think this works. I'm like not like 100% sure, but it feels right. So we just say, did this? Yeah, I'm like 75% sure that this does the right thing. I can't find the case that wouldn't work if we just and these guys together and look for if any bits are said. That's kind of sick. Okay, let's see if that works then. So let's look for the high lookup table. This is going to be a vector of 16 U8s, right? And this is going to equal, essentially we need to figure out these mappings, right? So any of the guys that start with, so at index 2, we write 7. Okay. At index 0, we write 8. And at index 5, 0, 1, 2, 3, 4, 5, we write 16. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I don't know if we were talking 0 index. I think we were. Low lookup table? Is... We're looking at the other side here. So we have to set 0, 0, 1, 2, 3 needs to be set to the hash to match this. 4 is 0, 5 is 0, 6, 0. The next one is A, C, and D. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A. So this gets the value for low n, which is 8 or 4. Then B, C, D gets the value for dash, which we wrote as 2. And wait, we missed C. C needs the value for backslash, which was 16. Why is 0x in front of 7? I don't know. It felt right when I did it. But you're right. Okay, I think that's right. So now we should be able to basically take the high bits and low bits of each chunk. So here we're going to batch these in 16s. Yes. And we're going to be like, we're going to load the input from IDX to IDX plus 16. We're going to load that into a vector. So bytes, right? So this is vector u816 equals this. And I think you might have to dereference like this. Okay. So then we are going to map each of these. So that's the shuffle command. He says, like, given this lookup table. No, first we're going to extract the low and high bits. So we're going to say bytes and 0xf. This is the low bits. And the high bits is the other way around. So we take the top half of these things. This is what we call this high bits and low bits here. Uh-huh. Okay. Then we do a shuffle, which is basically like lookup in the lookup table. And he takes in the type, so U8. B starting at -1. So we only need the lookups for positive numbers. So we're going to go low lookup table. And we're going to say undefined for B. And then mask is the actual thing. So that's low bits. Okay. This feels like it's going somewhere. Cool. And then let's do unreachable here. Because I don't know what to do next. I would like to just kind of look at this thing and see what comes out. I guess we then want to and the high bits and low bits. Or sorry, want the shuffled. So low shuffle here and high shuffle. We want and these together. Okay. So this is going to be like marked bytes. And can we do this is greater than 0? That'd be kind of hype. I don't know if this is gonna like if this causes branching. I don't know if we have to if this is bad. But I think it's probably fine. And then can we do like std debug print of the marked bytes and just see what happens. If we like call this function, yeah, I want to see what happens if we just call this. So can we call this with something a little bit more like interesting? So let's do, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. I would love to see something interesting happen there. Fuck. Found type. Oh, we got the fucking... Oh, I hate it when I get the order backwards. Is it really like this? Is it really? Yeah, it is. What the fuck? Every other thing in the language has the type first, and this time it's like, nah, type after. That's fine. All right. Index syntax required for slice type const u8. So how do we like assign slice to vector zig? I know it's possible converting slice to an array. Oh yeah, I thought you could do this. Then why is he unhappy? Am I stupid? Is it like this or something? Index syntax required. Here we go. Sure. I mean, we could just mem copy it into something. I guess you could do it this way, where you have like, can you do this? Surely not. Yeah. You could do like input is 16 U8s. Mem copy. I wouldn't be shocked if this is wrong. I just don't know what is right. And we're kind of just hoping this would get optimized out anyways. Input array. Like, is it like this? Mix scalar and, oh, sure. So this and 0xf. This needs to be a splat here as vector of 16 U8s. Splat this shit. Yeah. Okay. Unable to resolve comp time value. Did I get the shuffle params wrong? How do the zigzag shuffle? Mask needs to be comp time known. Oh, that's kind of fucked up. Do I have it backwards? Do I have it backwards? Each element mask selects an element for A or B. Pause a number select from A. I know you don't like double slicing, but you need it here. Ah! That's interesting. I didn't realize. So you're saying I can do this. IDX onwards from 0 to 16 star. You're saying do that. Yeah, okay. And now this sucks. I thought that this would work. Because I saw someone talking about shuffling this way. But it seems like if the mask needs to be known at comp time, then we're fucked. What about like, I saw at select as well. Selection element wise from A or B based off predicate. Yeah, that's not what I want either. God damn it. This is what I'm saying about shuffle. This is why I need VP shuff B. Yeah, that sounds right. That sounds right. What you were saying earlier, I think, doesn't exist in here. I think that's what you said. And then I ended up at that thing that you said I should read later, which I guess I will read now. Okay, blah, blah, blah. Here's the table generator, blah, blah, blah. Yep, so they're doing this. Okay. This isn't Zig? So how does he get this? I don't understand. Is this just a thing that we have somewhere? Or is it something that he wrote in C? Check his Galdbolt link to see how he gets it set up. Okay, so let's look for the first example of VP shuff B, and then we scroll down to we see something Godbolt. Oh. That's crazy. Sick. Wait, that's kind of hard. That goes crazy. Dude, I'll fucking take that shit. I'll fucking yoinkies that. I'm not above it. I'm not above it. That's kind of metal. That's super cool. I'm actually like, I've never seen. That's just very cool. Very cool. I won't be surprised if I need some sort of like magic here. Okay, so he's got the table. So we're using VP shuff B with low lookup table and low bits, and high lookup table and high bits. Okay. Here they're mad because I need to splat this 0 out now. I really wish, I mean, I understand why it's not, but man, auto splatting would be so hype. uh, did I just leave a 0 somewhere? Yeah, I did. All right. Okay. So now we got false, true, false, true, false. So we got lots of falses, 2 trues, which is not what we were hoping for, right? We were hoping for 1, 2, 3, 4, 5 trues off rip, followed by a lot of falses. So we've done something wrong. But I would love to see maybe what happened here. And we can see if we did something stupid. Okay, so high shuffle is just all 8s. Which means that everything is 0. Um, that is a good point, huh? No, that's not a good point. Because all of these 2s should be in here somewhere, right? So the fact that everything is 8 here is not... First of all, I change this to 9. That is getting me all 9s. So it seems to me like this high bits thing is not masking correctly. Oh, I'm a dumbass. We're supposed to do this shifted right by 8. That makes way more sense. And then here we probably have to like splat out an 8 here and then shift right like this. U3 cannot represent. Oh yeah, 4. My bad. Okay. Wait, so that's looking a lot better. That's looking a lot better. So we see 7, 7, 8. True, 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 true. Followed by all falses. Oh, baby! That's so sick. That is so sick. Okay, so now to just confirm that we really did get something that works right, I think what we should do is we should try to construct a string here that has every index, right? And check that this guy correctly identifies them all, right? Yes. So we can go back, we can try to finish this thing off, right? So we go here and we say, we just write to the output, I guess. So we say we have to figure out how to identify each of these. Which I guess probably it's okay for us to do this. I wouldn't be shocked if like Zig will do the right thing here if we iterate over the elements of marked bytes. I don't really know if this is reasonable, but so we'll say this is interesting. An index here, or offset, I guess we should say it. Then we can use index plus offset. If is interesting, we can say output offset plus index. Yes. Okay, so first of all, let's see if that gives us something sane. Pointless discard of output. So we should see here that we have like 0, 1, 2, 3, 4 in our output. Oh, we can't iterate this way. Can we do like this? This is marked bytes offset. Is that illegal? Okay, that is. So now if we look at the output file, which is called probably uppercase because we never changed it. Yeah. We see nothing. That's not good because out index has to be implemented here. Okay. Cannot assign to constant. True. This guy's always whining. So here we have 0, 1, 2, 3, 4. So that's working. And now we should be able to basically inject test data that's like test data is going to be 256 U8s. And we're going to set it by going 4, 0 it to 256. We say test data I is equal to I. Okay. And then we pass in test data here. And we should see 5 lines come out at the other side. Right? We should see that only the things that we wanted are correct, are flagged as interesting characters. 1, 2, 3, 4, 5. Tell me that's not fucking sick. Tell me that's not fucking awesome, man. Okay. So now can we run this on like our actual test data? Now we're going to run into trouble if it's not a multiple of 16. So I think that we can just for now drop the trailing bits because I don't want to deal with it yet. So here can we say, while this is true, and I guess this is while IDX plus 16 is less than input len. Yes. So now we should be able to run this on like the full fucking data. Which is printing like mad, which is annoying. So let's just get that shit out of the way. And can we do optimize release fast? And not cat this shit at the end? Okay. Which seems like it might not be very fast. Can we look at diff of interesting chars sample and uppercase? So we're literally only missing a couple, right? All of the rest, correct. We got everything right. We just missed a few. And now we can compare the fucking results. So we can look at poop, zig out bin, poop, and find interesting sample bin SIMD test and zig out bin SIMD test. And these guys should be doing the same thing. We should be able to compare them. And it will be interesting to see if we're any faster. If we're not any faster, that's really funny. Oh, come the fuck on, man! We like doubled almost. That's so fucking sick! Let's go, dude. And then can we see what like the compiler output of this thing actually was? Dude, that's so cool. That's so sick, man. I guess we need the v push b as well. Or else this won't compile. And then did I accidentally fuck something up there? No, we're good. Compilation failed. Oh, we need stood as well. And then it was also built in. Is import built in probably? I think you need to compile the others and release safe instead of release fast. I'm pretty sure I did. I'm like 90% certain that I did it right. So how do I like what am I looking at here? Oh, there's like loop unrolling. Oh, I see. So I bet you what we're doing here is maybe a little bit stupid. Probably. But that's what all this is. Then this is the core of like the interesting work. Yeah, so there's like, yeah, we're doing this is stupid, clearly. But we gained a lot of speed. But I think that you're also right that I should double check. I should be 100% sure that this is a fair comparison. So we'll say this is interesting cars manual SIMD. Let's do a. Oh, I didn't fucking save. I didn't. Oh, when I committed, these weren't in the fucking repo. No, so we've lost it. Um, I'm like pretty sure that this is correct. Pretty damn sure. Um, I don't really want to rewrite it right now. I don't. I'm fairly confident. In fact, we can probably even like search back in the history to figure out where that came from. Fine, interesting, simple. Right? We can go back. The scroll back isn't long enough because we fucking nuked it. Yeah, that sucks. Well, I'm sure there's more improvements to do here, but I am just very pleased with this. This is so cool. This is so cool. And you can kind of see how like spending some time thinking about math like lets you hit like mega speed up. That's so sick. But yeah, we're way past time. We're at 4:30, so I think we call it for today. This was fun. I don't know if we'll do more. We probably won't because like why would we? This whole thing is like this is just indulging ourselves anyways. Um but yeah, this is pretty fun. Thanks for watching, guys. If you like what you saw, we stream most days at 12:30 Pacific time to 4 o'clock Pacific time. It is 4:30 now, so you expect to see us online from 4 hours ago to half an hour ago would be like the typical time online. If you like the content, apologies, but I do have to say if you want it to continue for extended periods of time, it is time to start saying that, this content won't last forever if I cannot pay rent. So if you guys want it to continue and you have extra money to throw around, you can support on Patreon, YouTube, or Twitch. You get the happy hour VODs, the 12:32 segment by doing that. But otherwise, no big deal. 2 to 4 segment posted on YouTube, and 12:32 segment is catchable live on Twitch without paying. So it's not paywalled or anything, just archived is the thing for that. Otherwise, I think that's it. YouTube, peace out. Twitch, let's find someone to raid.